Welcome to the first class of machine learning. So far, we talked a lot about Bayes networks. And the way we talked about them is all about reasoning within Bayes networks that are known. Machine learning addresses the problem of how to find those networks or other models based on data. Learning models from data is a major area in artificial intelligence. And it's perhaps the one that had the most commercial success. In many commercial applications, the models themselves are fitted based on data. For example, Google uses data to understand how to respond to each search query. Amazon uses data to understand how to place products on their website. And these machine learning techniques are the enabling techniques that make that possible. So this class, which is about supervised learning, we'll go through some very basic methods for learning models from data, in particular specific types of Bayes networks. We will complement this with a class on unsupervised learning that will be taught next after this class. Let me start up with a quiz. The quiz is: what companies are famous for machine learning using data? Google for mining the web. Netflix for mining what people would like to rent on DVDs, which is DVD recommendations. Amazon.com for product placement. Check any or all, and if none of those apply, check down here. And not surprisingly, the answer is all of those companies and many more use massive machine learning for making decisions that are really essential to their businesses. Google mines the web, uses machine learning for translation, as we've seen in the introductory level. Netflix has used machine learning extensively for understanding what DVD to recommend you next. Amazon composes its entire product pages using machine learning by understanding how customers respond to different compositions and placements of their products. And many other examples exist. I would argue that in Silicon Valley, at least half the companies dealing with customers and online products do extensively use machine learning. So that makes machine learning a really exciting discipline. In my own research, I've extensively used machine learning for robotics. We see here is a robot my students and I built at Stanford called Stanley, and it won the DARPA Grand Challenge. It's a self-driving car that drives without any human assistance whatsoever. And this vehicle extensively uses machine learning. The robot is equipped with a laser system. I will talk more about lasers in my robotics class. But here you can see how the robot is able to build 3D models of the terrain ahead. These are almost like video game models that allow it to make assessments where to drive and where not to drive. Essentially, it's driving on flat ground. The problem with these lasers is they don't see very far. They only see about 25 meters out. So to drive really fast, the robot has to see further. And this is where machine learning comes into play. What you see here is camera images delivered by the robot, superimposed with laser data that doesn't see very far, but the laser is good enough to extract samples of drivable road surface that can then be machine learned and extrapolate into the entire camera image. That enables the robot to use its camera to see drivable terrain all the way to the horizon, up to like 200 meters out, enough to drive really fast. This ability to adapt its vision by driving its own training examples using lasers, but seeing out 200 meters or more, was a key factor in winning the race.